Welcome to today's math lesson on finding the area of composite figures. Our do now question reads, side lengths of the base of a triangular prism are 5 meters, 8 meters, and 10 meters. The height of the prism is 16.5 meters. As you can see, they've all been labeled on this diagram. What is the lateral surface area of the prism in square meters? So to start off, I'm going to highlight the base shape of the prism. So since it's a triangular prism, the base shape is going to be a triangle. And then I'm going to write out the formula for lateral surface area. So LSA is equal to P times H. P stands for the perimeter of the base shape. H stands for the height of the prism. So starting with the perimeter is the distance around the shape. So since a triangle has 3 sides, I'm going to add together 3 numbers. So in this case, we're adding together 8, 5, and 10. Since if this length up here is 10, that makes this length, the hypotenuse, also 10. And then I'm going to have to multiply the perimeter of the base shape with the height of the prism, which is 16.5. So according to order of operations, I have to do whatever is in the parentheses first. So 8 plus 5 plus 10 is 23. And then I'm going to multiply 23 times 16.5. Which gives me 379.5. The unit of measurement in this problem is meters, so our unit is meters squared since this is surface area. And if we have to bubble it in, I'm going to start with the decimal point. I know that 9 goes in front, 7, 3, and then behind the decimal point is a 5. And because there is no number that should go in the hundredths place, I'm going to just put 0. So then I'm going to bubble in the answer, 3, 7, 9, 5, 0. Today's TEK is 7.9C. Our lesson target is that scholars will be able to determine the area of composite figures containing rectangles, squares, parallelograms, and trapezoids. And the DOL is given 4 problems. Scholars will be able to determine the area of composite figures containing rectangles, squares, parallelograms, and trapezoids 4 out of 4 times or with 100% accuracy. So some academic vocabulary words for today include the word area, which we're focusing on, triangle, rectangle, parallelogram, circle, composite. So the new word is composite. Composite is means like composed of, which means made up of. So we're going to be finding the area of shapes that are made of other smaller shapes. And as you can see right here, it says a composite figure is made up of simple geometric shapes. So it can include triangles, rectangles, parallelograms, and circles. And to divide the area, to find the area of the composite shape, we have to divide the composite shape into simple, non-overlapping geometric shapes. Then we find the area of each simpler shape and then add up all the areas. And so this chart right here reviews some of the common area formulas. So for a triangle, it's half times base times height. For a square, it's side length to the power of 2 or side length squared. For a rectangle, it's length times width or base times height. Same thing for a parallelogram. For a trapezoid, it's half times height times base 1 plus base 2. The star reference materials also gives us the area formulas for the different shapes. So we're going to start off with this practice that is of just finding the area of these simple shapes before we go into finding the area of composite shapes. So for this rectangle, we have a side length of 3 and then another side length of 2. So we can either use the length times width or the base times height formula. And that would make our area for this rectangle 6 because we're doing 2 times 3 or 3 times 2. Then for this parallelogram, which looks like a rectangle, but it's been slanted, we're still using that base times height formula, so we have 4 times 2, which is 8. Then for this trapezoid, our formula is half times base 1 plus base 2 times height. So I'm going to write it out, half. Our first base is 4, so we have 4 plus our second base is 6, base length, and then our height of the shape is 3. So according to order of operations, I have to do whatever is in the parentheses first. So 4 plus 6 is 10, so now we have half times 10 times 3. And then I'm going to multiply, so we have half times 10 times 3 is 30. Half times 30 is the same thing as 30 divided by 2, which is 15. So as you can see, when we're finding the area, our unit is raised to the power of 2. So for all of these, the unit is centimeters squared. Then for this square, we're multiplying the side length by itself. So 2 times 2 is 4. So the area is 4 centimeters squared. For this triangle, our formula is half times base times height. So 4 is the height, 5 is the base, 4 times 5 is 20, and then half of 20 is 10. Lastly, for the circle, our formula for the area of a circle is pi radius square. And so we're just going to estimate that pi is about 3.14. Our radius is 2. So then we have 3.14 times 2 to the power of 2, which is 4. So if we multiply 3.14 times 4, we get 12.56. For this I have to find the area of the figure. So as you can see, it's not a simple shape. It consists of a parallelogram and then a trapezoid. And so our success criteria for today's problems are: 1, I can identify the simple shapes and appropriate formulas. So I just identify the shapes. Next, I'm going to have to identify the appropriate formulas. Then I can identify and substitute the values of the parts of the formulas. And lastly, I can evaluate and add the formulas. So starting with the area of a parallelogram, the formula is base times height. So then I have to identify the base value and the height value. So I'm going to highlight it. So my base for the parallelogram is going to be 10, and then my height is going to be 1.5. So to find the area of the parallelogram, I'm multiplying 10 by 1.5, which gives me 15. And since my unit of measurement is centimeters, it's going to be centimeters squared. Next, I'm going to find the area of the trapezoid. The formula for the area of a trapezoid is half times base 1 plus base 2 times height So since this base length of the parallelogram is 10, I know that this right here will also be 10, which is part of one of the bases of the trapezoid. And then the second base of the trapezoid is this 7 right here. Next, I'm going to have to find my height. So even though we have this 2 centimeters right here, my height has to be a straight line up and down, so a straight vertical line. So my height's actually going to be the 1.5, not the 2. Then I'm going to go ahead and solve it. So we have half times 10 plus 7 is 17. And then we're going to multiply the 17 times the 1.5. Which is 25.5. Lastly, I'm going to divide 25.5 divided by 2. And that gives me 12.75. Again, my unit of measurement is centimeters squared. And so to find the area of the composite figure, I'm going to have to add together the 15 and the 12.75. And that gives me 27.75. And then I can't forget my unit of measurement, which is centimeters squared. So going back to the success criteria, you can see that I identified the simple shapes that made up the composite figure. Then I wrote out the appropriate formulas for the parallelogram and the trapezoid. I identified and substituted the values of the different parts of the formulas into the equations. And then I evaluated or calculated the simple areas, the areas of the simple shapes, lastly adding them together to find the area of the composite figure. This next we have to still find the area of the composite figure with the same success criteria. As you can see, there are 3 smaller rectangles. I'm actually going to break it up into one bigger rectangle on the right and then one smaller rectangle on the left. So I'm going to number them. I'm going to say this is 1 and this is 2. And then I have to find the area of rectangle 1. I'm just going to simplify it to R1. So the area formula for rectangle is length times width, or base times height. So I'm going to have to identify the base and the height. So the base is going to be the 12. So I'm multiplying 12 times the height of the bigger rectangle, which is 18. 12 times 18 is 216 centimeters squared. Then for the second rectangle, the smaller one on the left, it's the same formula, base times height. And I've simplified it to area of R2 is equal to, the base is going to be 8, and the height is going to be 9. 8 times 9 is 72. And our unit of measurement is centimeters. So our unit for the area is centimeters squared. So now that I have the area of the 2 smaller rectangles, to find the area of the composite figure, I'm going to have to add them together. So the area of the figure is going to be 216 plus the 72. And that gives me 288 centimeters squared. There's some we do problems as well as some you do problems. And lastly, you have to complete your 4-question Google Form DOL. Thank you so much for following along in today's math lesson, and see you in the next math video.